Hello everyone, my name is Vitória. I'm a physics student at University of São Paulo. I'm part of the Laboratory of Archaeometry and Sciences Applied to Cultural Heritage, and I'm here to talk about the sensitivity curve of an X-ray fluorescence or PIXE system, a project developed under the supervision of Professor Marcia Rizzuto. Our motivation here is to determine the concentration of a chemical element in an X-ray fluorescence sample from its intensity data. We know that intensity is given by the total number of photons that hit the detector, which is given by the counts in the vertical axis, divided by the measuring time. So we have a quantity expressed in counts per second, and we want to relate the height of the peak with the concentration of this chemical element in the sample. Here we have the relation between intensity and sensibility. Intensity is equal to the concentration, what we want to find out, times the sensibility, times something called the matrix absorption factor, a parameter that has no dimension and is equal to 1 for thin samples. Sensibility is basically a parameter linked to the X-ray spectrometer and related to each chemical element of interest in the periodic table, and expresses the sensitivity of the system in detecting the spectral lines of the element. It is proportional to the system's geometry factor and efficiency, and to some fundamental parameters that are related to the excitation energy. And since these fundamental parameters are different for each X-ray line, we shall have one sensitivity equation for K line and another one for L line. What I did was the determination of the sensitivity curve of an X-ray fluorescence system with a fast SDD detector from UPTEC. And the results I found were compared to the results Javier, a collaborator of the laboratory, found to another X-ray detector called X123, also from UPTEC. And Javier also calculated the sensitivity curve for a PIXE system, and all these results are shown and compared in this presentation. So to determine the sensitivity curve, we use thin samples, which are elemental standards with well-defined superficial densities. And since we know the superficial densities, we are able to calculate the concentration of a given chemical element in the sample. And as I said, the matrix absorption factor here is equal to 1, allowing us to find the sensibility simply by dividing intensity by concentration. So what we need to do is obtain X-ray fluorescence or PIXE data of these elemental standards, find the intensities, calculate each chemical element's concentration, and divide intensity by concentration. Repeating this procedure to all chemical elements of interest, we can fit the curve of sensibility as a function of the atomic number and determine the sensibility equation. These are the results I found for the fast SDD X-ray detector. I fit a fifth polynomial degree for both K and L line. And we can see here that here in the beginning, the sensitivity is very small, and only here in the middle, it has nice values. Around atomic number 30, which is zinc, it starts to fall, and K sensibility is small again. And after atomic number 40, we begin to look at L line, and we see that it also starts with small values and then starts to increase. L line had a really good fit, but we see that around z equal to 40, the system has its worst performance in detecting the spectral lines, since both K and L lines are small in this region. So we conclude that the middle of the periodic table is the least well described by this detector. And these are the results Javier found. The scale of the vertical axis is different, but we can see that the system's behavior is very similar to the previous one. Both of these also begin with small values and reach its maximum around z equal to 20. The X-ray fluorescence system, the blue points, also have maximum between atomic numbers 20 and 30. And PIXE is a little bit shift to the left, here having its maximum around 17. Unfortunately, here in the region around z equal to 40, it also has small values, and we detect the spectral lines with less sensibility. So this is what I wanted to show to you guys. I would like to thank TUIFUSP and CNPq for the support, and the Brazilian Physics Society for this opportunity. Thank you for your attention.